Hi, welcome to an exciting adventure of Wernau does your homework for you. I'm just going to work, this is a couple questions from our worksheet on substitution. I just want to do a couple questions with you. Let's take a look at number 5 right here. Now number 5 is a tough one. So this is a u substitution problem, integration by substitution. So of course our u is going to be x squared. Give me a du is dos equis. Stay nerdy, my friends. 2x dx. dx therefore would be du over 2x. And when I rewrite this, we would get x cosine u du over 2x. Of course, those x's cancel, and I'm left with 1/2 cosine u du. Now, I am going to change my domain, so let's take a look here. When x is pi over 3, u is, well, pi over 3 squared becomes pi squared over 9. When x is pi over 2, u is just pi squared over 4. Ooh, these are nasty. So this is going to become pi squared over 9 to pi squared over 4. But this is a nice thing about calculus. We'll see this. When I take the antiderivative, we are going to get 1/2 the sine of u. Remember, the antiderivative cosine is sine of pi squared over 9 to pi squared over 4. Evaluating it using the fundamental theorem, f of pi squared over 4 minus f of pi squared over 9, and we're going to get 1/2 sine pi squared over 4 minus 1/2 sine pi squared over 9. We don't know either one of those, so we're just going to leave it. Don't be like a hero. But if I take the square root, I get pi squared over 2. We can't do that because that's not pi squared over 2. That's pi squared over 4. So leave it alone. Okay? So the trick is, most trig functions will have to know. Like if I said, what is sine of pi over 4, I'd expect you to know that. But not pi squared over 4. Alright, let's take a look at number 7. Again, I'm just going to work a few of these with you. We want to find the area bounded by this function, x equals 0, x equals pi over 2, and the x-axis. Now, we're going to talk more about this later on this year when we get to area between curves. But basically what we're going to do is we're going to graph this function, y equals sine of 2x. I really don't know what it looks like. Okay, that's it. We want the domain of 0, pi over 2, maybe it, maybe not, I don't know, and the x-axis. So if you notice, we have these 3 bounds right there. So we're looking for the area bounded by that. That's what that phrase, bounded by that. So I want to find the area. Well, what finds area? But the integral from 0, my x's go from 0 to x equals pi over 2 sine 2x dx. Again, we're going to use u substitution. U is 2x, du is 2 dx. dx, of course, is du over 2. Writing this all out, we would get 1/2 sine u du, and I'm going to go ahead and change my domain here. So when x is 0, u is 0. When x is pi over 2, u is just pi. And so I plug those in, 0 to pi, and now I can integrate. The antiderivative of sine is negative cosine u from 0 to pi, using the fundamental theorem f of pi minus f of 0. Notice this is not taking me very long. Negative 1/2 cosine of pi is negative 1 minus f of 0. Negative 1/2 cosine of 0 is 1. So let's see what this gives us. 1/2 plus 1/2. Oh my gosh, it's the number 1, just like your favorite calculus teacher, me. There's number 7. So let's see if there's any more we want to work on here. These are in our notes from before. We talked about these already. Let's see here. We talked about one like this. There's a circle. Ready? With the approximation of x cubed using a left-hand Riemann sum of 3 subintervals being an overestimate or an underestimate. So we don't have to really graph it. We're talking about a left-hand function. This is increasing. Look at your notes. See what that means for us. I guess one more thing I could do with you guys. This is a question that tends to pop up every once in a while. They will say, let's say the integral from 0 to 5 of f of x dx is 7. And then they tell us the value at 5 is 3. Find f of 0. This is a question that pops up. Now, this is an FTC problem, and the AP loves these problems right here. So if I set up with the FTC, the area from 0 to 5, f of x dx equals big F, no, that's like a little bit of a prime there, I guess. I should put a prime there. F of 5 minus f of 0. So this is my FTC step. I know that this area right here is just 7. Here's f of 5 minus f of 0. Well, I also know f of 5 is 3. So 7 equals f of 5. Whoops, sorry, it should be 3 minus f of 0. And I can solve that. F of 0 would be, of course, negative 4. So there I have my starting point. So they give me my ending point. Right here where I end, there's my starting point. Now, if you think of this as displacement, this says I've covered 7 feet. Well, I ended up at 3 feet. Where did I start? At negative 4 feet. Anyways, hope you guys enjoyed the videos. I'll see you later.